All right, so we're probably gonna start now. I guess people are kind of still rolling in, but like, you know, we gotta go. So, yeah. So I'm Sashko. This is Emily. I graduated from MIT in June and just got started at Meteor. Emily graduated in 2013.
Yeah.
Oh, it says on the slide. Yeah, with a master's degree, she's been at Meteor for about a year and a half. We want to tell you about Meteor and the kind of design decisions we made when people were coming out with the framework, and especially about our data protocol, which lets you sync your data between the server and the client. So first of all, what is Meteor? Meteor is an open source JavaScript framework that runs on the client and the server and lets you build applications really quickly. We think that it gives people like a 10x productivity boost over the previous generation of web frameworks like Django, Rails, that kind of thing, and lets you build the kind of apps that people are expecting really quickly and conveniently. So first, just to show you what Meteor is all about, let's do a quick app demo. So we're going to run one of the example apps that come with Meteor, which you can create by installing Meteor and running this command. So let me open up my bash here. I'll do bam. So now I've created my example. Go to my folder and I run Meteor. And now as soon as the server starts, I can go to my Chrome and go to my local host to see the app. So this is an app we call Leaderboard, and what it is it's a live scoreboard for a set of players. You can click on different players to select them, and you can give them points. And when you give them a certain number of points, they reorder because the list is ordered based on how many points you have. So there's a couple interesting things about this app. The first thing is, let's look at the code really fast, that there is no actual logic for like reordering the players, doing that kind of thing. You just run a database query and print it directly on the page, and it like reorders whenever it needs to. So in the place where we render the players, you can see it's just in each block over the players, and we can look at the JavaScript code where that's retrieved. We can say template.leaderboard.players is just this MongoDB query, which is run on the client, and it reruns automatically whenever the database changes when you click the button and give someone points. So you don't have to write any of that logic to rewrite stuff. So another cool thing is there's no like fancy framework magic going on. We can connect directly to the MongoDB database. We can say Meteor Mongo. And now if I do, let's look at what the Players, right. Is it find one? Yeah.
Pair programming.
That's right. So we can look at, this is the structure of the database. We just have some MongoDB documents. And if I do an update, so for maximum effect, I'm going to open Chrome in the background while I do my update. So now if I update the record where the name is Ada Lovelace, and I want to set her points, or her score, it is, to, let's say something so it reorders, so like 22, for example. And if I run this, you can see that the database query, which has nothing to do with the framework at all, updated the value in the database, and we use oplog tailing, which uses Mongo's replication mechanism to update your data on the client in real time. And so that's what Meteor is all about. It lets you do that kind of data syncing super easily without having to worry about all the mechanics. Huh? Oh, right. One more cool thing is just because all the data is in the database, thank you, Slava, for the help. If we open two windows, all the data is updated in any client that's connected, right? So if you went to this website on your computer, if we deployed it, it would update on your computer as well, which makes it super easy to write things like, chat programs, like real-time map updating things, and we'll get into that in a second. Right. So before I mentioned building modern apps, and the question is like, what are modern web apps? They're all of the like super high budget applications that you see and use every day, like Facebook, Twitter, Uber, that have all these really cool properties that make them really, really nice to use. So some of those properties are, they always respond instantly to your input, right? If you go on Facebook and you type in a comment and you hit enter, in the UI you see your comment update right away. Like whether or not the server has seen it yet or if it's responded, it doesn't matter. You want it to feel really snappy and like it's happening instantly. Next thing is that the UI on the front end is always up to date with the data on the server, right? If you get a notification on the server, your page updates automatically without you having to refresh or like query the server again for like new notification updates. It should just happen. As soon as the database updates, your UI should update. Then you want to be able to use it as if it's an application on your computer. When you open a new tab, you don't want to wait for all the HTML to load again. It should just load the application instantly, and then as soon as it connects to the data, it'll get all of your new data. Right? You should be able to click around the application before all the data is loaded, just like you would be able to in a desktop app. And the last thing that I'm mentioning here is all these apps have, they have a web app, they have a mobile app, Android, iOS, and what that means is you need to have a good separation between the data on your server and the presentation layer on the client, so you can like maybe write different presentation layers, maybe native code, maybe JavaScript code, whatever you want. And so let's talk about what you need in a framework to make this kind of thing possible and how we arrived at basically what Meteor is. So the first thing is you need to be able to do this thing called latency compensation, which is the thing I was talking about with the comments. You don't want to have to wait for the server to respond to show a simulation of what will happen on the client. Because every time you clicked to post a comment, it took like 3 seconds to do a round trip to the server, or whatever. That would totally suck. So you need the app to feel really snappy so it responds instantly to your input. To be able to do that, you need to be able to render the views directly on the client. Because if you're rendering all the HTML on the server, you still have to wait for that round trip to get your new view, which means that you need to be able to have all of the views on the client so that when that new comment data comes in from the user, you can just render it directly on the client using the client templates, and the server doesn't need to know anything. Now that you can render your views on the client, you need to be able to get the data from the server to the client somehow so that you can render it. So that you can update, for example, if you have posted a comment, but for some reason you're not logged in, you don't have permissions, something happens, the server will say, wait, hold on, no, you can't do this. And then it will send back a patch saying, that comment should be removed from the UI because it doesn't actually exist on the server. And to be able to do that, the server needs to be able to update the data on the client whenever it wants without the client having to pull. And then the last thing is to enable all this stuff, you need to have a client-side cache so that you don't have to make a request to the server every time you want new data. If you already have the data on the client, why not just use it there and render it directly instead of doing that round trip again? So Meteor has 5 main components that enable this whole thing. Basically, all of Meteor is built around that concept of having the snappy UI with latency compensation and automatic data syncing. So the first part is what we call live query, which lets you do queries in MongoDB and then get updates whenever there's new objects or changes that match that query. So let's say you go to a certain page, for example, on Twitter, you could search for a hashtag. That query in the database would first return you all the results for that hashtag, and then if a new tweet comes in, it will push that to the client automatically. And the way we do that is through a protocol that we call Ddp, the Distributed Data Protocol, which is a protocol custom built for syncing data and doing remote procedure calls, which we'll talk about in more detail later. The client-side cache that I was talking about in Meteor is called MiniMongo, and it replicates the entire API of MongoDB on the client so that when you want to render your views or do queries, you don't have to wait for the round trip to the server-side MongoDB. Next, we have a client-side component called Tracker, which lets you specify, or it automatically detects when functions have dependencies. So if your function depends on some data in the database, it reruns automatically when that data changes. It gets pushed to the client, Tracker finds out that this function is out of date, and it reruns it and does whatever effects it needs to do. And the last part is Blaze, which uses Tracker to update the HTML whenever that needs to happen. And it always does the minimal amount of HTML updates based on the data that has changed in your system. So just to be more clear, live query is the server part. The client part is MiniMongo, Tracker, and Blaze. And the thing that communicates between them is DDP, the Distributed Data Protocol. And Emily's going to tell you more about that now.
Okay, so I'm going to tell you about this protocol, DDP, and it's one of the backbones of Meteor, and I'm going to kind of walk you through it, explain what it's all about. Explain what it's all about. How close do I have to be? Is that good? Okay. And I'm going to kind of use it as a case study to show how this part of Meteor was designed to make these kinds of modern apps possible. So DDP is just a simple human readable protocol. It sounds kind of fancy, but it's actually just a simple JSON-based thing. You can look at the messages, you can tell what they're doing, and in fact, we're going to do that right now, and I'll show you an example of how we can use DDP for remote procedure calls and for data synchronization. So when a client uses an RPC to make changes to data on the client, the server then synchronizes that data to all the other clients who need that data. So let's go back to that demo app that Sashko showed a few minutes ago. And I'm going to use a tool called Ddp Analyzer, which one of our community members actually built. So I'm going to start this proxy, and this is just a proxy that is going to log DDP messages for us. So I'm just going to run the app with this proxy configured. And as soon as it starts up, we will go connect to the app, and then we'll see a bunch of kind of connection setup messages. So this is DDP. It's human readable, which is really nice. If you're debugging your app, you can kind of see what's going on, see what messages are going back and forth, and it's easy to figure out what should and shouldn't be getting sent. So you can see some messages here. The client's getting some data via these added messages. If I go select a player and give this player 5 points, you can see this message going out from the client to the server, and this is an RPC. This is a method call. So you can see the client's calling a method by sending this method message. This is the name of the method. These are the arguments. And at some point later, the client gets back this result message, and this is the return value of the method. And in between, you can then see this changed message, which is the server telling the client, hey, some data that you're subscribed to is changing. And it tells you the collection name, or the kind of like the table name if you're used to a SQL world, the ID of the document that changed, and the actual change that happened. And then we see this updated message, which is the server telling the client, you just ran a method. You've now heard about all the data that was changed as a result of that method executing. So this is what we call a write complete notification. This is saying the client knows at this point, has been told about all the data that changed as a result of that method. And I'll tell you in a little bit more detail about why we need that and what role it plays. So this is DDP. It's simple. You can look at it, see what's going on. And I'll just tell you a few more details about what the protocol looks like, what each of the messages are. It's very small specification. You can go look at it online. You can read it. There's just a few types of messages. So there's pub sub and there's remote procedure calls, as I said. So the pub sub messages are pretty much what you'd expect. There's a subscribe message where the client subscribes to a set of data by name. So in the leaderboard example, we might subscribe to the player's subscription. And then there's added, changed, and removed messages to specify how the data changes. So if a new document is inserted into the database, as Sashko showed, that would result in an added message going to the client with the new document. And there's also this ready message down at the end here, and what that is saying is when the client subscribes to a set of data on the server, there's some initial set of data, and the server sends all that down and then sends the ready message. So the ready message is a notification that the client has received all the initial set of data, and then after that, new changes might come in. So now there's RPCs, and this might seem like a completely different thing. You might wonder why we would even have RPCs in the same protocol as PubSub. And in the next slide, I'll tell you a little bit more about why that's a key design decision. RPCs are really simple. There's a method message which says the client wants to call a method with a particular name and with a set of arguments, and Meteor serializes and deserializes those arguments for you. And then there's a result method going from the server to the client, which is the return value of the method, very straightforward. And then there's the updated message, which is what I showed you, that is the write complete notification saying the server has now sent the client all the changes that were made as a result of that method running. So I said, why do you need these in the same protocol? And also, why do you need this updated message? It turns out that one of the key things about DDP are these two things working together, PubSub and RPCs, in order to enable that latency compensation feature that Sashko was talking about. So as a reminder, latency compensation is you type a comment and you click a button to submit your comment, and your comment should immediately appear on the screen and not wait for a round trip from the server. Then when the round trip to the server actually does happen, when the method executes on the server, maybe some of the actual writes that happened weren't what the client was expecting. Then the Meteor client needs to fix up whatever it did optimistically to reconcile it with what happened on the server. And this is where that updated message comes in. You need that updated message, and you need the RPC to be tied in with the pub/sub mechanism so that you know when the server side, when the server has sent you all the relevant writes for that method, and you can start to reconcile your client cache that you've written optimistically with the server data. So this is one of the key things that makes latency compensation possible in Meteor, is that we have pub/sub RPC in this protocol that's carefully designed to allow you to optimistically write to your client-side cache. And then eventually, you'll match it up with what actually happened on the server. So this is just an example of how DDP is designed to enable these features that you want in modern web apps that REST or other APIs may not have built into them. So in REST, you might poll to see when data has updated. You might get a response back that a particular write has completed, but you don't know about other writes that might have happened and in what order. You don't know. You don't have that moment baked into the protocol where you can start to reconcile your client-side cache with the data from the server. Another really cool thing about DDP that we're trying to do is make it the standard protocol for how you push live updating data around from clients to servers. And there's a lot of advantages to having one standard protocol, because the status quo right now is all these apps, Facebook, Twitter, Uber, etc. They all have their in-house proprietary custom protocols that they've designed to do things kind of like this. There might be, REST APIs like Twitter and Dropbox have their live updating REST APIs with their own kind of custom conventions. But once you have a standard protocol, A, it's just easier. You don't have to learn different conventions for every API that you want to use. B, you can build up a lot of tooling around it. So you can write a fuzzer for DDP. You can write a proxy like I showed you one of our community members wrote. There's just a lot of advantage to having one standard protocol that everyone uses and that you can build up tooling around. So in that vein, let me just show you a little bit of the way that you use DDP in Meteor. It's a really simple, nice API. You can see that you can publish and subscribe to data using a pretty easy to understand syntax. In this Meteor.publish function, we're returning what's called a database cursor, which is sort of a reference to the results of a query. And Meteor knows how to take this as the return value of a publish function and keep that publication up to date as data changes in the database. There's also a lower level API that we're not showing here that allows you to create a DDP publication out of data that may not live in a database. So you can publish something that you get from a REST API. You can publish something you get from a sensor. From any data source, you can create a DDP publication. So it's not limited to just database cursors. You can subscribe to a publication like so, just by specifying it by name. And when you do that, Meteor will take those data messages that come in from the server and insert the data into the client-side cache. So Meteor takes care of keeping the client-side cache updated with the data that you get from a subscription. For RPC, there's a similarly simple API. You can define a method that takes some arguments and does some database writes, maybe calls out to a third-party service, does anything you want. It can return values, and the client can call it just by using this meteor.call function. So now that you see a little bit of what DDP is about, I want to point out that there's a lot of cool projects you can do. You may be able to make use of it in your projects that may not even have anything to do with Meteor specifically. So you can build a DDP server client in the language of your choice. If you've seen it, it's a really simple protocol. It's probably implemented in a couple hours, and many community members have already implemented it in various languages. You can say take whatever hand-rolled live data API like Twitter or Dropbox and stick it in front of DDP to get a much nicer interface on top of it. You can build a data that replicates data across a mesh network, and you can check out the DDP implementations that already exist in various languages. Just Google for DDP Python or anything like that, and you'll find a number of projects. So I hope that you found that cool. We do this kind of stuff all the time. We're hiring full-time engineers and interns. It's really fun to design these kinds of things from scratch. Think about what's the app that you want to be able to build and what are the primitives that you need to build it, because they tend to not be the primitives that were designed 10 or 20 years ago for a completely different kind of site. So if you're interested or if you have any questions about anything at all, come talk to us. We'll be here for a while hanging out. Slava over here with the video camera is also a core dev, and Matt Arbesfeld, who you may know, was our intern this summer. He did awesome stuff. He built, with Slava and Sashko, they built our newly launched PhoneGap integration for mobile support, along with other really cool projects. So yeah, please let us know if you have any questions. We're happy to talk about it. And thanks for coming.
Yeah, and one additional thing that I want to mention is if you go to the jobs page, there isn't anything there about internships actually, which we should probably fix. But we're like looking for interns for any range of time. If you want to do a summer internship, 3 months, semester internship, 6 months, take a gap year, do a year. Anything is fine with us because we have tons of cool work and not enough people to do it. So, any questions?